In this video, we're going to finish talking about systems of measurement, section 11.1b. Now, I did realize that in our last class discussion lecture, I forgot to talk about temperature at the end of discussing English units of measurement. Okay, so we are going to finish that really quick. Actually, I will pair it, the temperature, when I talk about the temperature for the metric system, all right, which is what we're going to talk about now. So metric units. So here, I'll do it that way. Okay, so the metric system is used pretty much everywhere but America. And their system is a little bit more simplistic than the American system. So it won't take as long to go through. There is some prefixes that are really important that are used in the metric system. All right. So let me go ahead and I want to list those prefixes out. So there are the Greek prefixes. And those ones, Greek. There we go. Are kilo, hecto, and deca. Oops, kind of low on the screen, so the pen got mad at me. There we go. Kilo, hecta, deca, hecto, deca. So kilo, most of us have probably seen that before, means 1,000. Hecto means 100. And deca means 10. So those are the Greek prefixes that we'll be using in the metric system. And then there's the Latin prefixes. And those are used for the smaller values. Deci, centi, and milli. Deci means 1/10. Centi means 1/100. Here, I probably should do. There we go. 1/100, and milli is 1/1,000. So when we're talking about the larger amounts, we would use the larger units, kilo, hecta, deca. When we're talking about small amounts, small measurements, we'll use the Latin units, deci, centi, and milli. All right. There are other prefixes that are used, micro, nano, tetra. You've probably heard those, giga, but we won't be really focusing in on those for the systems of measurement. Okay, so just like with the English units, there are different categories we're going to look at. So let's start with length. So in length, the common unit for measurement is the meter. But it is variations on the meter that we find interesting. So if I use these prefixes on the meter, so for instance, if I say kilometer, that would mean to you 1,000 meters. Hectometer would mean 100 meters. And sorry, I should have put in parentheses that just the single M represents the measurement meters. Decameter means 10 meters. And then, of course, there's just the meter itself. All right. Oh, here, that would be 1 meter. There you go. For consistency. Okay, and then we have the decimeter. Now, based on the prefixes, the decimeter is 1/10 of a meter, but you could also think of it as 0.1 meters. We could think of it in decimal form. Then we have the centimeter. That's 1/100th of a meter, or in decimal form, 0.001 meters. Sorry, 0.01 meters, not the other one. That's when we get to millimeter. And last is millimeter. that is 1,000th of a meter, or 0.001 meters. There we go. All right. So these are or can be thought of in decimal form as well as fractional form, but they are talking about smaller measurements. All right. So I would encourage you, I am going to create an activity since we're doing this via video to kind of complete, to talk about doing some measurements. And I think it'd be kind of interesting to talk about, but sometimes it's useful to kind of think of, okay, so what size measurement makes sense based on what we're kind of talking about here. Okay. So like, for instance, if I asked you, let me switch to pens here, blue. So let's say I asked you, let's say I wanted to find the length of, oh, how about a pencil? How long a pencil is. It might be kind of useful to know which unit of measurement might make the most sense for that. So we kind of do want to know somewhat of an idea of how much a meter is so that we know what measurement would make the most sense to use. So a meter is about, here, let me use my green pen, is approximately 3.28 feet. So that's good to kind of know. Help to relate it to the measurements we're familiar with. So if I wanted to find the length of a pencil, and I think most of us would think, okay, so I'd get like a ruler. Well, you probably have seen on a ruler centimeters. And therefore, it would make sense to say that centimeters would be a reasonable measurement for a pencil. But I think it's also important for us to kind of understand centimeters is relatively close to inches, and kind of understanding that helps us. Decimeters isn't used very often, interestingly enough. We're pretty comfortable with centimeters and millimeters because it is used a lot more. Same with kilometers, larger units of measurement. But yeah, we typically skip over. Let me just kind of star the ones that aren't used as frequently. Hectometer, decameter, and decimeter. They kind of get ignored a little bit. In America, we don't see them as much. And we have worked with centimeters, millimeters, and kilometers, I think a lot more. But we do want to kind of have a sense of how to look at it. So if we know 1 meter is about 3.28 feet, almost three and a quarter feet, then it kind of gives us more perspective when you're talking about 1,000 of them and what that's really closer in relation to in length. All right. Okay, so that's something you want to kind of understand when looking at the metric system, is kind of having an idea of how it relates to us. A decimeter wouldn't be all that crazy to do on a pencil as well. A decimeter is not very far away either. A centimeter, though, is pretty easy for us since we do typically have that on our rulers. All right, the next unit of measurement is volume. And in the metric system, volume is measured by liters, which uses a capital L. Okay, so let's go through the prefixes again. Kiloliter. And I'm probably not going to do this much longer. But kiloliter, you know what I should have done? Let me backtrack here. I should have labeled the measurements too for each of these, like their little representations. So let me do that really quick. So this also equals 1 kilometer. This is 1 hectometer, 1 decameter, and they use an A to distinguish it from decimeter. So a decimeter, it just uses the D. So 1 decimeter, 1 centimeter, and 1 millimeter. Sorry, I should have labeled them also for the labels that they take on. Okay, so for kiloliter, a kiloliter is 1,000 liters, and it uses the KL. So it uses the same measurements. Then we have the, hectoliter, which is 100 liters, or HL, deciliter, 10 liters, 1 DAL, and then just the liter itself. And then the deciliter is 1/10 of a liter. Centiliter, 1/100th. Oh, that's so funny. Where did that come from? Who knows? That should have been a DL. And CL. And then a milliliter. And this is the ones we're familiar with. Interestingly enough, okay. Sure, there we go. There's somebody else. And ice. I got a little lost there. All right, 1 over 1,000 liters, or 1 ml. So we're used to seeing kiloliters and milliliters. We are definitely not nearly familiar with the middle ones. So for that one, those would be the ones we would star. These are the ones we don't know as well. We work with liters. That's not unheard of course. 2-liter bottles. We all know what that is. But yeah, we definitely have this, certain ones we're not as used to. Okay, now, interestingly enough, I am going to do some conversions here with the volume in just a second. But there is an interesting connection between the volume and some cubic information, which I'll talk about in a second. All right, so before we get there, let's go ahead. I already had it on blue, and do an example. Let's convert 1.3 liters into milliliters. All right. Now, based on our work when we worked with the English units and doing the conversions, we can set up a conversion for this to make it work. But as I mentioned, the metric system is very well behaved. And here's where the good behavior is going to come into play. So rather than set up a conversion, no, I'm going to set up the conversion. I'm going to show you what the conversion looks like. And then I'm going to show you why it's well behaved. And you might even know why. So if I wanted to convert 1.3 liters, into milliliters, that means I need to multiply it so that I'm left with milliliters. Okay, so I need to know how many liters and milliliters, what the conversion is. Okay, so since we know a milliliter is 1,000th of a liter, that means that 1 liter is 1,000 milliliters. That's what the conversion says. So this comes out to, those liters cancel, and this comes out to 1,300 milliliters. Okay, but this, what I wrote here, isn't quite what we wrote up here. What we wrote was that a milliliter is 1/1000th of a liter. So I'm kind of understanding that that's the same thing as saying that 1 liter is 1,000 milliliters. So I kind of took for granted that we could understand that. Okay, but here's why this system is so nice. Because we're always multiplying by tens or hundreds or dividing by tens or hundreds, all we really end up doing is moving the decimal. And if we understand that when we convert from liters to milliliters, we're going from a larger amount to a much smaller amount, smaller unit of measurement, that means the number is going to get bigger. And instead of using our multiplication, we can move the decimal based on the multiple of 10. So because we're multiplying by 1,000, that's 10 3 times. So we would move the decimal 3 places, or for 3 zeros. And that would leave me with 1,300 milliliters. Let's try that again. This time, let's do 245 milliliters. 245 milliliters equals how many liters? All right. Okay, so now we're kind of going the reverse way. We're starting with the smaller unit of measurement and we're converting it into liters. So in this case, then, we're taking the decimal, which happens to be after the 5, and we're going to move it the other direction 3 times to the left, which would then be 0.245 liters. Or we do the multiplication conversion, 245 milliliters, timesing it in the reverse direction this time, 1 liter over 1,000 milliliters, and then canceling them and still getting the same answer. Except now we're dividing 245 by 1,000, which is 0.245. So it does behave really nicely like that, as long as we know which one's bigger and which one's smaller. So therefore we know which way to move the decimal. All right. Okay, let's try one more. Let's convert 3,487 liters into milliliters. Oh, sorry. Kilometers. Wanted to do something different. Okay, so we're going to use our decimal trick. Currently, the decimal is right after the 7. So 3,487. And since we're converting to kilometers, that means then that we are going from a smaller unit of measurement to a bigger unit of measurement. So we're going to move to the left. And we will move it. So kilometers, there is 1,000 kilometers. I'm sorry, 1,000 liters in 1 kilometer. So 1,000 again is our magic number. So we're moving it 3 times. So that comes out to 3.487 kilometers. I'm sorry, kiloliters. Wow. Stumbling over those measurements. All right, nice. Okay, so I mentioned that there was something kind of bonus with volume here. Let me do it. Thank you so much. Okay, here's the bonus with the volume. So volume, and we're going to actually talk about this more in 11.3. Volume is this idea that we are interested in a 3D object and how much space there is. So here, I'm going to draw an open box here. And we're interested in how much we can fill in this space. That's volume, right? So if I were to create little cubes that I'm stacking in here, tiny little cubes that I fill this giant cube with, all these little 3D cubes. I'm doing a terrible job of drawing it. That's fine. Stacking in little 3D cubes. All right. That measures volume. So we typically use in metric system the cubic centimeter. So one of these cubes in centimeters can be thought of as having 1 centimeter on each side and is 1 centimeter cubed. So they call this a cubic centimeter. Wow. That's an I and not a weird R. What the F? Should have been an I in there. Sorry, centimeter. Cubic centimeter. 1 cubic centimeter happens to equal a milliliter. So milliliter is measuring volume as well, and it is equivalent to 1 cubic centimeter. Since that's the case, and a milliliter happens to be, or I should say, if I wanted to think of how many liters would equal cubic centimeters, okay? What if I'm interested in that? 1 liter would equal how many cubic centimeters? So if 1 cubic centimeter equals 1 milliliter, and 1,000 milliliters make up a liter, that would mean 1,000 centimeters cubed equals 1 liter. So we have this kind of interesting little conversion between milliliters and cubic centimeters. All right. So we can use that information. I believe they have some homework questions on that. Okay. Now, in the English system, we use weight, but in the metric system, they actually like to use mass. So mass is a little bit different. Mass is the amount of matter that makes up an object. Whereas weight takes into account gravity. So weight is using Earth's gravity in its understanding and calculation, whereas mass is going to be the same regardless of the gravity. So if you and I were to go to the moon right now, we're going to all weigh lighter. All right. We're all going to weigh ourselves and we're going to weigh lighter because the gravity in the moon is lighter than the gravity on Earth. But our mass would remain the same. So they use mass in the metric system. There is that distinction between the two systems. And I do want to mention, another note, that 1 kilogram, actually here, before I do this note, sorry, I should have said, so they use, to measure mass, they use grams. I'm not going to write all of the prefixes, kilogram, hectogram, decagram, decigram, centigram, and milligram. Okay, they're all similar, but they use grams. And now I'm going to do my note. I should have said that first. 1 kilogram, which would be 1,000 grams, is approximately equal to 2.2 pounds. So we can talk about the weight conversion on Earth since we are talking about Earth. So on Earth, 1 kilogram is approximately 2.2 pounds. All right. So if I wanted to do a little bit of converting with that, let's say, let's find the mass of a 140-pound person. All right. Okay, so let's go ahead and set this up. So we have 140 pounds and we'd like to find the mass. So I'm going to convert it basically into metric units. And I have this one thing they told me, and that was that 1 kilogram equals 2.2 pounds. So I'm going to put 2.2 pounds, on the bottom for my converting. And 1 kilogram here at the top. And that should cancel the pounds. So I'm going to grab my calculator and figure out what 140 divided by 2.2 is. I come up with 63.6 kilograms. So that's the mass of a 140-pound person. Nifty. All right. Now I've gotten to temperature, which I had wanted to talk about. I forgot to mention that at the end of the section when we talked about English units. But temperature is kind of a funny beast, right? We have two ways we measure. We have a couple ways. Wow. The way we measure temperature here in America is the Fahrenheit system. So the English units. Oh, I should look up the spelling. Hold on. There we go. Fahrenheit. But for the metric system, we're mostly familiar that they use Celsius. It's kind of low on the screen, so it's getting mad at me. Wow, it really is just an angry computer. Celsius. That's a S, not a C. Sorry. Celsius. All right. But they can also sometimes use Kelvin, all right, the Kelvin scale as well. Okay, so for the Fahrenheit temperature, water boils. Here, let me actually put it above. So water boils. For Fahrenheit, it boils at 212. Wow, 212 degrees Fahrenheit. And for Celsius, it's 100 degrees. And then we have water freezes. So water freezes at 32 degrees Fahrenheit. It's sad looking too. Let me fix it. Wow, it just erased the 3. 32. There we go. But for Celsius, it's 0. So again, they're kind of sticking with tens and hundreds and multiples of tens. So the Celsius system is kind of still sticking to that. They created the system based on those two measurements, 100 degrees to 0 degrees. All right. Then I mentioned that there is the Kelvin system. So, let me say this properly. I'm sorry. It says it increases 1 unit for each increase of 1 degree Celsius. Okay, that doesn't make sense. Let's just do it this way. 273.15 on Kelvin is 0 degrees on Celsius. So Kelvin is special. Kelvin is used in science. They use Kelvins like talking about temperature of planets that are so hot that it seems ridiculous to use our measurements. All right. So that's how they kind of do the scaling for Kelvin. There's like a very different scaling for Kelvin. All right. And I think that's it. So I am going to be giving you an activity. Please just look for that on Canvas. And that's it, guys. Thanks.